right?
Yes.
All right, perfect. And you hear me okay? All right, so if anything goes wrong, somebody please shout at me. Right, so yes, I'm Hans G0 UPL, Golf Zero Uniform Papa Lima, and Dan invited me just a few days ago to speak here, so thanks very much for the invite, Dan. And Dan suggested that I talk a bit about the history of QRP Labs and how it came to be where we are, and also the products, the kit range that we have, and something about building kits. So I want to go all the way back to my beginning. And the first section, I just want to talk about my pre-QRP Labs years. This should actually say 1976 to 2010, which is when QRP Labs started, not 2020. So all the way back, this was my first radio in 1977. It was a 6th birthday present, and crystal radio set. Many years ago, I found these parts and still have them. And so took a photograph. So that's what really got me started into radio. And, you know, I was amazed to see that I could hear these stations on this tiny thing I'd built with no battery or anything like that. Then moving on a bit, 1982, I built this 4-transistor regenerative receiver with my father, transistor receiver. And moving on a bit further, 1988, I built a tube.
The slides are not moving.
The slides are not moving?
Nope.
What do you see on the screen? Which slide do you see?
We see the first radio.
And when I move it, you don't see it moving?
No, we're seeing the regular PowerPoint screen with all the PowerPoints on the left and your highlighted PowerPoint on the middle.
Ah, I see.
You have to share the other screen.
That's right. Okay, in that case, that means I'm sharing the, when I play the PowerPoint, when it goes full screen, I need to share the whole screen, not just the window.
Correct.
Okay, here we go.
Like that. That should be better, hopefully.
That's got it.
You got it.
So where I was at was the tube regenerative radio, 1988, that you can see there. Then in 1994, I'd finished university and I got my license, Golf Zero Uniform Papa Lima. And the first kit that I actually built, so this was my introduction to kit building, was a British kit by a company called Wolford Kits. It was a 160 meter double sideband transceiver, an SA602 based double sideband transceiver. And I was operating this in my apartment in London with a antenna, which was just a wire round a drain pipe, a helical antenna, and it was indoors. And not surprisingly, I heard nothing at all. And I used to listen to this for days on end and heard nothing at all, let alone was able to speak to anybody. And in the end, I did hear one CW QSO between a Greek station and Italian station, if I recall. And that was all I ever heard on it. But anyway, it was a good introduction to kit building. I then had some dark years where I did nothing at all with radio. But then in 1999, I started my website, hanssummers.com, which became very popular. And I put more and more projects on there that I had built, my personal projects. And it wasn't until 2002 that I had my first ever contact, and it was all building, all using homebrew kit, which I built myself. And still to this day, I only have homebrew radios in my shack. I have no commercial gear at all, just the homebrew radios. And this particular one used a 1-tube CW transmitter, 80 meters. So it had a 3.560 QRP calling frequency crystal, and this triode pentode tube that you can see there in the picture. And I built that from single-sided SRPB PCB material into a chassis and an ATU into an aluminium enclosure. The key there is a key that I had inherited from my father. I'm not sure if he was a radio amateur or not. I don't think he ever was a radio amateur, but he had this key anyway, so that came through to me. the receiver was made up of a direct conversion receiver with phasing method for unwanted sideband cancellation, and was my first foray into phasing method, direct conversion, and quadrature sampling detector, all of which became very strong themes in QRP labs later, and indeed at the moment. As you can see, I put a lot of effort into this radio, and I had a clock in the top left and a frequency counter in the top right. And those were also both homebrew, my own design, all discrete TTL digital logic chips, no microcontrollers. And so it was quite a huge project. It took a very long time. Back in the first QSO, it was all spread out there on the bench. But here you can see the final version all packaged up. This contained a number of modules, which I used to say was basically a love letter to Pat Hawker, G3VA, because Pat Hawker wrote a column in the RSGB Radcom magazine every month for 60 years without missing a month, as far as I understand it. And his technical topics column was 3 or 4 pages of technical articles which he'd come across in publications around the world or people had written in. And this receiver was basically made of ideas which came out of his column, as indeed was the transmitter. The one tube transmitter was also from his column, but all the things that were in this transmitter, particularly the Taylor detector, quadrature sampling detector, and this Huff-Puff stabilization method for VFOs, all of that had come out of the G3VA column, which I had been reading over the years. And I'd put those modules together to make the receiver. Then in 2003, and coming on to this weak signal niche of our hobby, which is a whole different topic all by itself that would be well worthy of its own presentation, but it's basically sending signals very slowly, and as you do so, you then use a computer and a sound card analysis program on a computer, such as Argo, the screenshot I'm using here, to demodulate those and display them on the screen. The advantage of the very, very slow sending is that you have a very narrow bandwidth, and that gives you a very high signal to noise ratio. And so 100 milliwatts is easily enough for worldwide transmission, but of course you're sending information very, very slowly. So I hope I'm still audible and there's no problems with audio. Please shout if anything stops. So you can still, can somebody confirm that you can still hear me okay?
Good.
Okay, great. So I built this thing all out of discrete TTL and an EEPROM memory chip, and it was all programmed by those buttons and switches to produce the sequences in the correct time. And this is important because the sensible way of doing this is with a microcontroller, an Arduino or something like that. But I had done it with all discrete logic that had interested me at the time. But I became very interested in this tiny niche of the hobby. And this was actually pre-WISPR, a weak signal propagation reporter, which is a very popular activity now. But back in 2003, that hadn't been invented yet. And I think Joe Taylor developed that sometime around 2007, 2008, something like that. So roll on a bit to May 2009, and I was invited to the Dayton Hamvention and the QRP Amateur Radio Club International event, the 4 days in May event, and I was inducted into the Hall of Fame. And it was a great honor to be there, and the first time I'd been to the Dayton Hamvention, and very much enjoyed that, and particularly the flea market. And then the following year, the same year, but a couple of months later, I developed this very tiny radio transmitter, which was a QRSS transmitter that just transmitted my call sign, the last 3 letters of my call sign, UPL, in very slow frequency shift keying QRSS mode. And as you can see, it was very tiny. It fit inside a mint tin. And I took that with me on holiday to the Caribbean, to Grenada in the Caribbean. And that's why I called it Tropical QRSS. And it just ran during the week or the 2 weeks that I was there onto a hastily put up dipole antenna, and was copied all over the world. And I actually built this transmitter in 2 hours before leaving to the airport. And I started at 3 o'clock in the morning and finished at 5 o'clock in the morning, and packed it all up in an ice cream box with some antenna wire and took it with me. And so it was a very hastily built transmitter, but it worked very well. And we had a very nice holiday. And as you can see, I had a small local fan club there. You can see in the top right as well. Now, this now leads on to the second part of what I want to talk about, which is the beginning of QRP Labs, because 1 year later, I was invited back to Dayton for the FDIM conference to give a presentation on these weak signal modes. And to accompany that presentation, Steve G0XAR, a good friend of mine in the UK, and myself, we decided to produce a simple kit that would accompany the presentation. And this kit was basically the same circuit, the same schematic that I had used on that tropical QRSS transmitter. So you see how I led to this point talking about that. And so after, after my presentation to the FDIM conference, I announced that I had bought these 100 kits and we were selling them for $15 each. And in the microcontroller, the 8-pin chip that you can see at the top left, I programmed all the operators' call signs who purchased the kit individually. And this generated a whole pile-up at the vendor evening at the FDIM event, which you can see there in the photograph. And there was a queue, a lineup snaking around the room for 3 or 4 hours to buy this kit. It took me a few minutes to load the call sign into each chip individually, one by one, on the laptop and program them as people came by to purchase them. And so it was a totally unexpected success and tremendously popular. And that's what started QRP Labs. And so it was the first kit. And when I went back to UK, Steve G0XAR and I continued to produce this kit for several years. And then eventually there was a problem with a clone of the kit, and it made us very angry for a while, but eventually it encouraged me to develop an improved version. And we called this the Ultimate QRSS Whisper Kit, because it transmitted not only the weak signal modes, but also Whisper, JT4, JT9, JT65, lots of these new digital encoded modes which had come along in the intervening years since my first QRSS transmitter. And so this one had the much larger Atmega 328 microcontroller. You see here, this 28-pin chip, and it had a low-cost LCD display and 2 buttons on the board here. And so it enabled the user to program their own call sign into the transmitter and choose what mode they wanted and so on. And so it was a very big advance on the first kit because it didn't need individual programming specific to each user. And so that was very important from our perspective as kitters, because it reduced the manual overload, but it also was very important for the user because it provided so much flexibility that they could configure themselves. And this was the first kit for Whisper. In fact, the previous kit had been, the QRSS kit had been the first kit for a QRSS transmitter. And this was the first kit that allowed Whisper standalone with no PC required. Up until that point, generating Whisper had involved a PC feeding audio to a single sideband transceiver. And so it was quite a nice step forward in that regard. So then I moved to Tokyo, and in Tokyo, I was there for my work. I was working in IT in investment banking and had a job in Tokyo. So I was there from beginning of 2011 until mid 2016 and continued developing the kits at a quite a low level. And this was my lab, QRP Labs headquarters it was the bedroom closet, and I squeezed into there a small desk from IKEA and a small chair and all of my test equipment, and I did all the kit developments and everything in there for many years, and it was only 5 by 4 feet, so it's 20 square feet in total, and I fit everything into there, so it was really compact. And then I continued evolving these kits from the Ultimate 2, which was shown there at the top right in the photograph, which used the same display, but the advance here was that it used this AD9850 DDS board, which was available quite low cost from eBay and other Far Eastern sources, as well as a plug-in low-pass filter board. And so it provided the opportunity to operate across more bands. The previous kits had been a crystal oscillator and were limited to the crystal frequency, but this provided an opportunity to operate across more bands with a high degree of precision that could be generated by the DDS module, which is the blue board that you see there. And then the U3, the Ultimate 3, was the third version in the series and is shown in the bottom left photograph. And that added this 16 by 2 character blue backlight LCD display that you see in the bottom right there. And it still used the AD9850 DDS and as a plug-in module, so it allowed all of this flexibility. And the other thing that the Ultimate 3 allowed me, because I had moved to using this 16 by 2 display rather than the monochrome with no backlight single line display that I'd used in the Ultimate 2, was it allowed me to have more spare I/O pins on the processor and control other things. So I developed a 6-way relay board, which I'll come on to in a moment, which allowed the microcontroller to sequence between up to 6 different bands and transmission modes and so on. So the Ultimate 3S on the bottom right was a further minor improvement to the Ultimate 3, which replaced that AD9850 DDS board with a SI5351A synthesizer board, which I developed. And the reason for that was the AD9850 DDS boards, during the few years that I was selling the Ultimate 2 and then the Ultimate 3, I had purchased 2,500 of those modules from China, and the supply had dried up. And so the price had gone from about $4 per module at one point up to $8 or $9 per module. And in fact, now you can still buy this module if you go on eBay, but the price is now about $13 or $14. And so I had bought so many of these to sell in the kits, which had become so popular that it just kind of priced itself out of being economic. So I had to develop a replacement module, which was this SI5351A kit. Excuse me. And so now moving on, I'm going to talk about about the Ultimate 3S and some of the modules that go around it. And it became a whole modular system which plugs together and can be extended in different ways according to the constructor's wishes. And so for many years, this was the flagship product of QRP Labs, and many thousands of these had been sold. As I said, it produces a whole long list of whisper modes. And once we'd put the SI5351A synthesizer onto it, it was able to cover all the way from the 2,200 meter band, LF, it's a 136 kilohertz band, all the way up to the 222 megahertz band in the US, and all the bands in between. So I produced low pass filter kits for all of those bands, and it could just plug in whichever band you were interested in using. And everything was based around this 80 by 36 millimeter PCB, which held the microcontroller and the sockets for the synthesizer and the connectors onto the LCD module. And the reason for the size is that it's the same size as the LCD module. So it stacks behind the LCD module with these plastic hex spacer mechanical assembly. And that's still a very hot seller in the QRP Labs kit range. And so it really, I've been developing these weak signal kits since 2010, all the way up until 2020 today. And this is the current version of that, the Ultimate 3S. It's $33, and that includes the SI53518 module as well as the low pass filter module that you plug in. But as you can see in the photograph there are lots of options which go with it, which I'm going to briefly talk through now so that you can see how the system can be extended as you wish. And the first of these is I think these are not necessarily in chronological order of how I developed them, but in the logical order to me of how to explain the modular system. So the first was this aluminium enclosure, which is has the LCD cutout in the front panel and the holes drilled for buttons and switches, and it comes with the buttons and switches and connectors on the rear panel. Being 16 centimeters deep, there's lots of space inside as well for not just the Ultimate 3S, but all the different modules which you might want to add to it. And you can see in this picture on the previous slide, somebody here has added the relay switched filter board here in the middle. So there are 6 low pass filters installed, 5 on that board and 1 on the main board. And then they've included here on the back the GPS receiver kit, which I'll show in a moment as well. So that's the enclosure, and it's a very popular item. For many people, soldering is something they can manage, but metal bashing is another challenge altogether. And making especially that neat rectangular cutout is something that is quite tough for many of us with a limited mechanical tool set. So moving on, this is the SI53518 synthesizer module, which I mentioned. And this miracle SI53518 chip, which you can just about see hiding behind one of the 0.1 microfarad capacitors there in the photograph in the middle of the board, is a PLL synthesizer on a chip, which has a range of 3.5 kilohertz output to 200 megahertz and beyond. And it's all configured by a microcontroller over the I2C bus, which is a serial communication protocol. And so I produced this module that plugs into the Ultimate 3S and acts as its oscillator. It also contains level conversion ICs because the chip runs at 3.3 volts and the microcontroller on the U3 runs at 5 volts. Sorry, not level conversion ICs, level conversion transistors, which you can see there, and it contains a voltage regulator. And I should say that many of these modules are popular in their own right for hobbyists as modules in their homebrew projects, not just for modules that are plugged into the Ultimate 3S. There was also a OCXO version of this synthesizer, oven-controlled crystal oscillator, which provides much higher frequency stability because it's got an ovenized 27 megahertz crystal inside the oven compartment. And this is basically a single PCB, 10 by 8 centimeters, which breaks into 15 smaller parts, and they're all soldered together in a precise way to create this oven enclosure that you see there in the bottom left photograph. And as far as I know, it's the only kit-built OCXO that exists in the world or ever has existed in the world. And it's quite a successful kit. It's very fiddly to put together. I think not really necessary for most people's use of the Ultimate 3S unless they wanted to do whisper on 2-meter band or something like that. For most people, the oven oscillator is not really required, but it's a nice challenge to put it together, and it's a very neat mechanical assembly. And it also includes the SI53518 chip, so it's completely pin compatible with the basic simple version of the module here and plugs into the Ultimate 3S in the same way. Then there's the low pass filter module, which is a standard 7-element Butterworth filter, and I have versions of this, as I mentioned, from 136 kilohertz up to 2,200, up to 222 megahertz, and a 2-meter band, 4 meter, 6 meter, 10 meter, all the way down through HF, and all the way down to 2,200 meters. And again, this module, it's a 1.5 times 0.5 inch PCB, and is popular in its own right for people producing their own homebrew projects, not just for use in the Ultimate 3S kit. Then this is the 6-band relay board that I mentioned, and as you can see, it's got slots here to plug in 5 low-pass filter modules on the PCB itself, as well as 1 low-pass filter module on the main Ultimate 3S PCB in the stack. And this is actually the first iteration of the board. The more recent board has got pin header connectors, so you can fit jumper wires and configure it in different ways so that the filters can be configured either with the highest low pass filter always in circuit, and which reduces the VHF harmonics more, or with all the filters connected just as a parallel arrangement, so one of them is enabled at any time, and that's useful for switching bandpass filters. It also has on the right hand side, the most recent version of the kit has an SMA footprint for an SMA connector. Some people like to do that. Then there's this GPS receiver kit, and this arose because I was supplying GPS modules for a while that I had purchased in bulk for use with the Ultimate 3S kit, but they all had various problems, like they required 3.3 volt power supply. Many of them required pull-up resistors to convert the 2.8 volt logic that usually is coming out of these GPS chips to 5 volts for the Ultimate 3S kit. And so I decided to make my own GPS module, and it's a relatively large PCB, as you can see. And the reason for that is that, like any other antenna, a patch antenna, and in this case the onboard patch antenna is installed on the other side of the board. The patch antenna requires a good ground plane under it, like any other monopole antenna, so-called, like a quarter wave vertical. You need a radial system of ground plane underneath it. And it turns out that many of the GPS modules that you see, which are very small, are actually compromised on their antenna and have quite poor sensitivity. And so if you use a really full-size ground plane, this is 65 millimeters by 65 millimeters ground plane underneath the patch antenna, you get a very, very high sensitivity. And so this works indoors. It doesn't need to have a view of the sky. People have even written saying it works in their basement and things like that. So it also contains a voltage regulator so that you can operate it from 5 volts, and a proper digital logic level converter, which is the 14-pin chip that you see there, to produce 5-volt logic for the Ultimate 3S. And it has these 3 LEDs which are installed on the reverse side of the board so that you can immediately visually see what's going on, whether you have the right power connection to the chip, to the RF module, and whether you have serial data and 1 pulse per second coming out of it. So it's a very useful debugging tool. Then I developed this receiver module, which is still on an 80 by 36 millimeter PCB, and it's a very high performance module that uses the TALO detector, the quadrature sampling detector. It also includes these 2 600 ohm isolation transformers, which are intended to get rid of ground loops. Ground loops can be a problem when you're feeding a sound card, and this is designed to feed a sound card. It produces an IQ output, which is used for software-defined radio programs running on a PC. There's also a slot for a bandpass filter, so it's a single band receiver, and bandpass filter plugs in, and it requires an external local oscillator to generate the signal required for the mixer, the quadrature sampling detector. When used with the Ultimate 3S is configured such that when not transmitting, you can use this receiver module, and it's all optimized for whisper whisper reception at 1500 hertz audio. And so this allows the Ultimate 3S to also receive whisper to be decoded by a PC. For the people who wish to have a single channel SSB demodulated output rather than needing a stereo sound card and then SDR on a PC, there's this plug-in module which has a phase shift network to cancel out the unwanted sideband. And this plugs into sockets on the receiver module, and produces this single channel audio suitable for mono sound cards from one of the outputs of the connector on the receiver board. Then there's a range of bandpass filters, and for 10 different bands from 160 meters to 10 meter bands. And these all plug into the receiver module in the socket that you can see here on the left of the board. And they're also the same size as the low pass filter module. So they're 1.5 times 0.5 inches. So they can be used on the relay switch module kit as well. And this is quite a popular option for people building their own receiver, because it immediately takes away the problem of designing the front end bandpass filters for the receiver and the switching of those. Then there's a Class C 5-watt power amplifier kit, and it uses a single IRF 510 as the amplifier device, and it works from 160 meters to 10 meters. You do need a low pass filter after that. It includes the heatsink as well. And a key feature of this is that it's got this raised cosine envelope shaping built into it. So it's got an 8-bit digital to analog converter that's on the right-hand side of the circuit board there, and it produces this very, very clean raised cosine key shape. That's something that's loaded. It loads the coefficients in to the digital to analog converter from the Ultimate 3S, but it also can be used standalone with a microcontroller plugged in there instead. So that's a very popular addition to the Ultimate 3S as well. Now, that's the end of all the modules that fit together with the Ultimate 3S. But after a while, I started also designing these other kits, which sort of complemented the Ultimate 3S. And this Shack Clock kit actually uses the same PCB and the same components as the Ultimate 3S. You just don't install the power amplifier components, and you don't install the SI53518 module and the low pass filter. And so it's a cheaper a kit because it doesn't include the SI53518 synthesizer or the low pass filter. And this provides a very nice, most people are purchasing it with the GPS kit. It provides a very accurate Shack clock, and you can decode other elements from the GPS data, such as the latitude and longitude and Maidenhead locator grid square. It has a very configurable display, so you can choose what you want to have displayed on the screen. You could display UT, or you could display local time, date, all of these features. And it also can control alarm outputs such as the relay board. So you can control all the relays on the relay board individually as individual alarms on this clock kit. And there's also an optional enclosure that goes with it, which is the same enclosure as the Ultimate 3S enclosure that you saw earlier, but just with different printing on it and different connectors at the back. Then I developed this VFO signal generator kit, which again is also the same PCB as the Ultimate 3S PCB, but now with an additional rotary encoder to do the tuning. And it supports features like a IF offset for superhets, and it can generate the BFO signal for a superhet as well as a VFO signal. It has this quadrature output mode, which can be used for directly driving the quadrature sampling detector type of mixers. And you can connect GPS disciplines, so you have very precise 1 Hertz precision VFO. And again, it can control relay outputs, so that you can choose to control up to 6 different low-pass filters and generate a sine wave output by filtering off the harmonic content of the square wave that's generated by the SI53518. And so there's a lot of features, and it's a very nice, convenient way of controlling the SI53518 synthesizer. The synthesizer and the rotary encoder are both included in that price that you see there, synthesizer module kit, as well as the VFO kit. Then there's this Arduino shield that I developed, and the reason for this was because the source code for the QRP Labs is not open source, and there were some people who wanted to do their own code, and so this allowed them to plug this shield onto an Arduino. You can see it there in the photo on an Arduino Uno, and it provides an interface to many of the other modules which are in the Ultimate 3S system. such as the SI518 synthesizer and the relay board, the low pass filter kit, and it has an onboard power amplifier as well that goes along with the kit, the same power amplifier on the Ultimate 3. Sorry, I've gone in the wrong direction there. Then there's this is another controller for the SI53518 and includes the synthesizer kit again. And it's a very, very small board that is a programmable crystal, and you can configure it to produce up to 3 independent outputs. And there are 8 banks of frequencies. So there are 3 input signals that you can use to choose between one of those 8 banks of frequencies. And there's on the right there, you can see this 4-way DIP switch, which is used for programming the frequencies into the module 1 digit at a time. Or if you prefer, you can connect it to a serial port and you can do it all over a terminal emulator on a PC. So that's quite a popular board and used often as crystal replacements. If you want a customized frequency crystal, the single crystal will cost you usually more than this kit, and this kit can be reused again and again. The frequencies are all stored in memory, so that once set up to produce the frequencies, it just operates and produces them every time it's powered up. Then this very simple dummy load, which is just 20 1K resistors in parallel. There's also an RF detector included, so you can connect a DVM and have some idea of power output. And again, that's quite a popular kit and a very low cost dummy load kit. As far as I know, there are no other dummy load kits at such a low price as this one. And then finally, there's this 10-watt linear amplifier, which was developed to go in the QSX single sideband transceiver kit that I've been developing for a couple of years now, and is so far the only module that's available for that. And this produces 10 watts power output for all of the HF bands, so from 1.8 megahertz to 30 megahertz. It's a true 10 watts power output, even in continuous duty cycle modes, such as digital modes and CW, or in CW, as well as in sideband. So from 12 volt or 13.8 volt supply, it produces a 10 watts output. There's a quite large heat sink here, which is to dissipate the heat that's generated in continuous duty cycle modes, such as digital modes. It actually has a driver as well as the final amplifier stage, so it produces 26 dB of gain, very flat across all of HF, plus or minus 1 dB across all of HF. We also tested it very rigorously without generating any failures by much too high power supply voltage, up to 20 volt supply, by a full 1 hour of full power 10 watt 100% duty cycle, and didn't generate any failures. Various open load mismatches, short circuits, bad SWR and everything, and it was entirely indestructible, didn't oscillate, didn't produce any nasty effects. So it's a nice module for people wanting to design their own sideband transceivers, or for people waiting to use it in the QSX transceiver when that comes. So that really finishes the sort of development of QRP Labs from 2013 until 2016. And in 2016, I decided to do QRP Labs full time. I'd been working for 22 years in IT, in investment banking, and enjoying the first few years, but as time went on, it became very stressful, and I was not doing software development anymore. I was doing management, and there was more corporate politics and people problems than there were technical challenges. So I decided to do QRP Labs full time, and we moved to Turkey at that point in mid 2016. There was no further point in being in Tokyo, Japan, so far from family and friends. So we moved to Turkey, where my wife is from. And we have in our home an attic office on the top floor, which is 350 square feet, about 35 square meters. And as you can see, I have a very messy desk that you see there on the left. But I have all the space to develop the kits and very happily do so in a much larger space than the 20 square feet that I had in Tokyo. And we also have 2 people working with us, a third one joining us in a couple of weeks' time, who handle the shipping of the kits and packing of the kits, and also handle some assembly of kits. So we have a QCX transceiver, which I'll come on to in a moment, and we produce it in an assembled version too. So the photograph on the bottom right side actually includes my 2 children and is taken during the coronavirus pandemic. And so school had closed down and they were at home all day. And so it was hard to keep them out of the office at some times. And so there they are in that photograph, helping or hindering, depending on which way you look at it. And so anyway, fortunately, they're now back at school, and so they're much happier than hanging around the house all day. So I'm sure many of you will understand it was quite a difficult period for a few months, particularly for children. Children were not allowed out of the house at all, and for at least 3 months here. And so it was a very difficult time. So now coming on to the QCX transceiver, which became the new flagship product of QRP Labs, and many of you will be familiar with. This transceiver has now sold over 11,000 kits since 2017, which is a absolutely shocking number. It's been very hard to keep up with, and it's just a single band CW transceiver. So whoever said Homebrew was dead or CW was dead was obviously mistaken, because 11,000 kits in under 3 years is an extremely high number. So how this kit came about? Well, in 2017, the RSGB were hosting the Youngsters on the Air summer camp in 2017 in the UK. And I had this email from the RSGB, from the organizers of this event, and they were looking for somebody to design and produce a kit to be used on one of the days of the event as a kit build-a-thon. And so I had this email, and the email said, we have £1,000 to spend, and we have 78 attendees from different countries, and what types of kit could you offer? And I looked at that email and I saw that £1,000, and I converted that to dollars, which is how I tend to think of everything. And it came to $16 per kit. And I just laughed at that, and I deleted the email, because I thought, what kind of reasonably useful kit other than a very simple toy could you produce for $16? You couldn't. But then over the next few hours, this problem wouldn't leave the back of my head. And I started thinking, well, what could you do for $16? And if I produced 500 kits and I sent 78 of them to the UK for this build-a-thon, and the others I sold at a profit, would I subsidize those, and what could I do? And I started thinking about ways to do it. And within a few hours, I had gone to my email, deleted emails folder, and had undeleted my email and come back with this proposal to Steve Hartley, who was running the build-a-thon on the RSGB side or event, and proposed this CW transceiver kit, which, you know, there are various very low-cost CW transceivers, such as the Pixie and various other transceiver kits that you can certainly get for $16 or less from the Far East, but they're often with very low quality, and they have very limited functionality, very low power output, poor performance, and so on. And so what I wanted to do was to produce a really high performance kit, a high performance radio transceiver that would encourage the youngsters to use CW and to get into building their own radios rather than discourage them. And I had myself built a Pixie transceiver kit and been very discouraged by the performance and the operation of it several years before I had built my transmitter and receiver kit that I showed you earlier in the photographs. And so I myself had been disappointed by that. So I really wanted to make something that was high performance, and this was what I proposed. This is a copy of the email which I wrote back to Steve. I proposed something with what later became 5 watts of power output, a single band with a proper synthesized tuning, rotary encoder tuning, a screen with iambic keyer included and CW decoder included, and a really high performance single sideband reception rather than a double sideband direct conversion simple receiver. And I also wanted to put a Morse key onto the board so that the youngsters would be able to use it directly without necessarily having to plug in a Morse key, which many of them probably wouldn't have, particularly at the event. And so without waiting for the answer from the RSGB, which actually took several months to, I think 2 months or 3 months to make the decision. And of course, I gather they had written to other kit companies and asked for their proposals as well. Without waiting for the answer, I developed my kit, and I think within about 10 days, I had my first QSO. And as you can see, I'm using the front panel here from an Ultimate 3 enclosure, and behind that is an Ultimate 3S board with the processor on it. So everything was all hacked together, bits and pieces, to produce this design. Now, the key features of this design with a very high performance receiver that using the Taylor detector, quadrature sampling detector. And as I mentioned, I had the SI53551A VFO. The NC2030 transceiver was by the NorCal Club, designed by Dan Taylor, and used a phasing network direct conversion receiver. And I actually used the same phasing network. So there are 2 operational amplifiers with some resistors and capacitors which perform the 90-degree phase shift. And that is based on the same circuit used in the NC2030. There's a very sharp CW filter, which is based on the 4 States QRP Club design, the Hypermite CW filter designed by Dave NM0S, who was happy to let me use that in the QCX. And then there's a Class E power output stage, which was very important because it has high efficiency and doesn't need a heatsink on the transistors. And another very important feature was built-in test and alignment equipment, because many of the people, certainly the constructors and certainly the ones in the original Youth on the Air event, didn't have test equipment to use. And so it includes all of its own signal generator and equipment to set up and align the receiver, as well as the message and frequency memories and the CW decoder and keyer, as I mentioned. And it also includes a whisper beacon function. So when you're not using it as a CW transceiver, you can use it as a whisper beacon or even a CW beacon. And it continued the QRP Labs ethos of low cost, high performance, high value kits. The full specification is listed here. Probably I don't have time to read through all of that, but it really produces a very high performance transceiver with features that you expect on a much more expensive radio, such as dual VFOs and split operation, RIT, full break-in, and so on. By the way, there's also this CAT control port in recent firmware editions, which allows you to connect it to your favorite logging program. This is just a brief list of the built-in alignment and test equipment tools, which allow you to set up the transceiver alignment very precisely without any additional test equipment, and also can be used as standalone test equipment for use in debugging if there are any faults in the transceiver, for example. This is my son, and when he was 21 months old, he came up to the lab and he saw me developing this prototype, and he told me to get off my chair, and he climbed up on the chair instead and started pressing the key and operating the radio into a dummy load, of course. And so I grabbed the camera, and that became quite a famous photograph, and because it's a very sweet photograph, and he'd obviously seen me keying the Morse key on the radio and decided to have a go himself. So this became a phenomenal success story, and in less than 3 years, more than 10,000 of these kits were produced and sold. And the youngest constructor I know of is 12-year-old Lauren there in the bottom left picture, who I met at a Hamvention in the UK. And there's a 91-year-old constructor there on the right-hand side. And so over 10,000 kits sold around the world was a huge number. There was no kit enclosure sold with the kit or available from me. And so constructors made all kinds of creative ideas on enclosures that they. So these are some examples of photographs I have received of the enclosure. Then a German company decided to produce official enclosure for the kit, and we sold them from the QRP Lab shop for a while, and then they're still available from this German producer still today, made out of bent aluminium, and that was very popular and contained shaft extensions for the buttons and the rotary controls, so that the radio could be installed in the box without any modifications and without mounting controls off board and so on. Then last year I developed this 50-watt power amplifier kit for the QCX, which includes a low-pass filter and can be built for 80, 40, 30 or 20 meters. And it also, very importantly, in which it consumed a lot of development time, it includes a pin diode transmit receive switch. So it has very fast and very quiet full break-in operation, which is supported by the QCX. So when you use this with a QCX, you can hear the band in between your keying symbols, your dits and dars. You can hear in the band completely the same as you would on a QCX, even though you've got 50 watts of power output. There's also a nice optional enclosure, and this price here includes 2 large heat sinks, which are used to dissipate the power. Also at the bottom right, there's an oscilloscope trace of the envelope of the RF signal, so you can see it's got a nice trailing edge on it rather than a hard stop which would generate key clicks. Then in May 2020, I upgraded the QCX to a radio which is called the QCX Plus, and it has the same, exactly the same schematic and firmware and operation and performance as the original QCX, but it's a much larger and less dense PCB, so it's easier to build. And so it also adds a CAT control connector and a PTT connector suitable for driving the 50-watt power amplifier, and an on-off switch, as well as an optional enclosure. The price increased slightly from $49 for the QCX to $55 for the QCX Plus. And in the few months since May 2020, this has been another tremendously popular kit, and people really like the professional appearance. It has a sort of front panel style, conventional front panel in an enclosure. So this is what it looks like inside the enclosure. And you can see the much larger board and the 2 boards, the front panel and the main board, which are connected together by pin header connectors. There's another picture showing the enclosure from the side, and here's the rear view with all the connectors on the back. So really, really sturdy enclosure, quite solid and robust and very professional looking. There's also a TCXO option, which provides very high frequency stability. It's useful if you want to do whisper, and particularly on higher bands where the temperature rise inside the enclosure could cause drift of the crystal. So it's a very small board with a rectangular cutout which fits over the SI5351A chip and sits nicely in the board. There's also this development kit which can be fitted on top of the board and has a 0.1 inch matrix, so people can build their own modifications to it if they wish. Now some statistics about the QCX and the QCX Plus. To date, there have been 11,189 QCX sold, and that's a really big number. The first 500 kits was a tremendous sellout. They were all sold in just 28 hours after the launch of the, so that was the balance of the first batch of kits after the kits sent to the YOTA event. Around 40% are sold to the US customers, and about 45% of people choose the 40 meter band option and 40% choose the 20 meter band option. So those are very popular options, those 2 bands, 40 meters and 20 meters. Then the new QCX Plus, over 90% of customers also choose the enclosure, 50% choose the TCXO, and 25% choose the dev kit options. Now, this is the current development. I'm nearing the end of the presentation here, so I'm hopefully will finish in a few minutes and we can have some Q&A. This is a miniature version of the QCX Mini, QCX Plus. So many people said that the QCX Plus is very nice, but there were several people who said, well, it's bigger than the original QCX and it's not so suitable for portable operations such as SOTA operations. So the new QCX Mini is going to be about the same price as the original QCX Plus, but it's going to be very much smaller. So it's 3.7 by 2.5 times 1 inches. It also has a reduced current consumption, which is achieved by using lower power op amps and being able to switch off the backlight to the LCD display. So I have some more photographs of that. I've built the prototype and I'm now in the manufacturing stage of the kit. So I'm preparing the board assemblies and manufacturing the enclosures. I'm preparing 1,000 of these kits and they should be on sale in November 2020. So they're going to be a very nice Christmas stocking filler, I think, for many people. And it will fit nicely in a Christmas stocking, of course, too. Again, it has the same software and schematic and everything as the original QCX. It's just a much smaller presentation using a lot of surface mount components, which are installed by the factory, by the way, so there's no need to solder those. This is a picture of the 3 boards that make up the assembly inside the enclosure. One has the controls, one has the LCD, and then the other one has the main circuits of the transceiver. That's a picture of the main board. As you can see right in the middle there, it has the TCXO board installed as well. And still the same through-hole 28-pin DIP processor chip, so it's easy to upgrade the firmware if you wish. Another kit which I've had in development for a couple of years is this all-band, all-mode 160 meter to 10 meter transceiver kit, which is an embedded SDR kit, again with an optional enclosure. This is way behind schedule. I still have no availability date, but it's something that is taking up a large proportion of my attention. So just a quick word about producing kits and how they're produced. Designing the circuit is only one part of it. You then need to do a PCB layout to make it something that can be mass produced for kit production. The firmware development takes a huge amount of time. Modern kits and modern electronics, a lot of things are controlled by microcontrollers. That provides a lot of flexibility to add things to our projects. And then there's documentation, which is another huge time consumer. All of the QRP Labs kits come with very extensive documentation to make building the kit quite easy. The component procurement and production of the kit and the logistics of getting all of these components here to me in Turkey, and then fulfillment, which is shipping out all the kits to the customers. And of course, I should have added on that list after sales support too. If people have problems with their kits, it's all tremendously time consuming. And so developing the original kit is probably 5% of the job, and the other 95% is all the hard work that comes afterwards. So why build kits? Well, it's a very fun and educational, very satisfying thing to do. And when you've really soldered together every component yourself, when you actually then come on to use it, you'll feel a very big sense of satisfaction. It's also very educational and teaches you how to build and design electronic circuits, and many people then go on to design their own homebrew circuits themselves for the next construction that they do. And of course, they can be modified more easily and repaired more easily. You built it, so if anything goes wrong, you're much more confident to repair it than you would be delving into an ICOM or a Kenwood, etc. The QRP Labs kits come with very extensive documentation, as I said, and very high quality PCBs, professional quality PCBs. Excuse me. Where there are SMD parts, and some of the kits inevitably contain SMD parts, these are factory soldered, so they don't have to be assembled by you, the constructor. There are also troubleshooting guides and videos, and there's a community on the groups.io discussion group of constructors that are always willing to help people with problems. So building kits, minimum tools that you need for building the QRP Labs kits. Of course, you need a decent soldering iron. I don't think it's necessary to go to a full-blown temperature controlled expensive soldering station, but certainly if you go to your hardware store and you buy the cheapest soldering iron which you can find, those are quite hard to use. So I would recommend a decent soldering iron. Most people agree that conventional lead tin solder is much easier to use and more reliable than the modern type of silver-based lead-free solder, which is quite hard to use and not very reliable in most people's view. This is a picture of the solder which I use, which is produced here in Turkey, and it's a 60% tin, 40% lead mixture. You need wire cutters and you need a screwdriver. DVM is useful, particularly for checking the enameled wire on the toroids has been stripped properly and you have continuity through those, and for debugging. An oscilloscope is useful for debugging, but not essential. Hopefully, if the kit works, you don't need an oscilloscope for debugging it. And of course, a lot of debugging can be done just with a DVM. Reading the manual, I've put here in bold red because that's the most important thing that you need to do. And it's also the thing that most people don't do very well. People tend to skip important parts of the manual and lose important information, which it comes back and bites them at the end. If you really don't want to build, then there's an assembled version of the QCX Plus, which we produce here. And as I said, I have 2 or 3 colleagues here who also work on assembling these kits, as well as the kitting and shipping. And it includes the installation of the TCXO and the enclosure option, if those are purchased, as well as the testing and adjustment and calibration. So final slide has got further information on it, the website for QRP Labs. You can email me, sales@qrplabs.com, qrp-labs.com, or hans@qrp-labs.com, or find the contact form on the website. There's also the user group, the QRP Labs user group, which has got thousands of members and are very helpful with solving problems or sharing their stories of using the kits. There's a Facebook page and there's a YouTube channel. In the YouTube channel, I've got troubleshooting videos. I've got videos showing how to assemble and set up and align the QCX transceiver. And I've also got a recent shack tour video. So if you want to see more about the shack here, the lab here, and how we go about producing the kits and developing the kits, that's an interesting video, which I recorded a couple of months ago. So that's QRP Labs and an overview of the products. And I very much intend over the coming years to develop more high performance, low cost kits, both transceivers and other kits. Things are definitely moving more towards SDR and digital operations. And I will keep the QCX kit going, but as I said, the QSX, the future all band, all mode HF transceiver kit will be an embedded SDR kit, and in that way you're able to add more functionality and performance and also lower the cost. So things are definitely moving towards SDR. So with that, I thank you very much for listening and watching, and I hope there haven't been any problems with the audio or my dry throat, and we can take some questions if there's any time for that, and if anybody has any questions. Thank you very much.
Well, thank you. And we got a lot of time for questions here because I'm sure we got some questions after the go. If you would raise your hand using the method we talked about earlier at the bottom of your participants thing. If you have a question, we can call upon you, or you can put it in the chat. We have people, and be sure to put a Q in front of the question. Are there any questions out there? And you want me to, can I down your screen? You have you're still,
yes.
Yeah, you're still sharing
yes.
your.
Is that better? I've stopped sharing.
Okay, that's better. Now we can see
Yeah.
if the hand's up.
Yep, now we can see the whole thing. Okay, I have a couple of people helping out here, so you'll see them coming and going. I don't see any hands up right now. That means you did a pretty good job of answering the questions through the presentation. Is there anything in the, yeah, here's one in the chat. You want to take that one, Barry?
Yes. The kits used to be sent from Japan. Are they now being shipped from Turkey?
Yes. So I was, as I mentioned, living in Japan from 2011 until 2016. And I really started getting serious about QRP Labs from about 2013 onwards and developing new kits. And I had a couple of ladies helping in Japan with the shipping. When I left Japan and I moved to Turkey, they carried on sending them from Japan for a while. But when the QCX was launched, the QCX popularity was so fast and so huge that those two ladies in Japan who were just part-time, they couldn't keep up with shipping the kits. And so I decided I had to move everything to here in Turkey, where I'd be able to, if necessary, employ additional help to get things shipped more quickly if we needed to. So the kits are mostly being shipped from Turkey now. We do still have some, we also have a US stockist in Missouri who has stock of some of the kits. And so particularly the most popular one, the QCX, he has stock of those QCX and he is able to ship those more quickly. We also have, since February this year, a corporate contract with FedEx. And so we are able to offer FedEx shipping as an option. That starts at $11.99 for anything up to half a kilogram, which is just over 1 pound in weight. And anything up to that weight is $11.99. And then the next shipping bracket is $19.27. And so the FedEx shipping is very effective and takes 3 or 4 days, business days to reach anywhere in the world typically. And particularly during the coronavirus pandemic, it's been very useful for us because it enables us to ship things out very quickly. Post office shipment has been really, really slow during the pandemic, in some cases taking 3 or 4 months. So yes, mostly everything is shipped from Turkey, but some of the popular items for US customers, the QCX is shipped also from Missouri.
Okay. Lee, you're on there. You want to take the next question off the chat?
All right, then. Start with a couple of comments here, if you don't mind. Let's see, excellent presentation. Hans, thanks for the presentation. Question, the kits, oh, sorry, that's already been done. What is the power output of the Mini?
The power output of the Mini is also 5 watts. So it's the same schematic and firmware and everything as the QCX Plus. And it has a 5 watt power output. The power output, like all the QCXs, does depend on band and on supply voltage. Usually we can get at least 5 watts power output with a 13.8 volt supply. Usually a 12 volt supply will give at least 4 watts output. And so that applies to the QCX Mini the same as the QCX Plus. It's all the same schematic. And in the QCX Plus, I actually bolted the 4 power transistors to the PCB using a nut and bolt. And so it's quite good for heat dissipation. And because we had some problems with overheating transistors on the original QCX, particularly if people were trying to run Whisper, which is a continuous 2-minute transmission in the Whisper beacon. So on the QCX Plus, that doesn't happen. So yeah, QCX Mini is just absolutely identical. It's just a smaller board using some surface mount components to make things smaller, a miniaturized QCX, but apart from that, it's the same. So yes, 4 watts with 12 volts, at least 5 watts with 13.8 volts.
Thank you, excellent. Any thought as to an AGC circuit?
Yeah, that's the only thing that has been missing really from the QCX, and debatable. Some CW operators say that you don't need AGC. Some people think that you do need AGC. I personally haven't missed having AGC on it, but then again, in my location in the southwest corner of Turkey, I don't have any radio amateurs for miles and miles around me. And so I don't have any strong signals from neighbors blasting my ears or anything like that. And so maybe it changes if you live in an area where there are a lot more hams. And so AGC circuits, again, it can be modified, and the QCX Plus is very modifiable with its dev kit board, and people have added things like batteries in the top of the compartment, and small audio amplifiers and speakers, and adding an AGC circuit would be possible there. With the QCX Mini, I forgot to mention one of the things I wanted to do with QCX Mini was minimize the development time, because a lot of people are waiting for the QSX transceiver kit, and I didn't want to take too much development time. And so I didn't want to modify the circuit. I was thinking about adding the AGC circuit, but in the end, I decided I'll just keep the circuit the same because I don't want to increase the development time. But it could be something that's added in a future version of the kit, a future modification of the kit. Certainly in future kits that I produce, like the QSX, which will be an embedded SDR, AGC and is definitely included on that. But on the QCX, it would be something that has to be added by the constructor at the moment. It's not included. Yeah.
All right, thank you. Good. Yeah, it's having a front row seat on watching the development. Thank you for that. There's somebody with their hand up. Do we want to take that one, Dan?
Yeah, yeah, go ahead, Lee.
Oh, okay. Ed, go ahead and unmute K9EW. Okay, take it away.
Okay, Hans, I still have your original Whisper kit that you mentioned that you would program at FDIM. And as a matter of fact, I'm in that picture that you showed. I've upgraded now to your U3S Whisper kit, and I have two antennas, two 40-meter antennas that I want to compare. And I like to transmit into one, and then a couple minutes later, transmit into the other, and back and forth. So I get a real-time comparison. How can I do that and maintain the identity of which antenna is being used?
Yeah, this is something that has been done by a few people, and there are a few different ways of doing it. But one of the easiest ways of doing it is using the relay switched filter kit, which provides, as I said, up to 6 different slots where you can plug in different low pass filters. And you could quite easily, this filter kit in the current PCB revision has pin headers so that you can configure it for in different ways. And you can actually configure it if you want, so that each of those slots has a different antenna connected to it. And so you can quite easily, if you wanted, build, for example, I don't know what band you're interested to operate on, but for example, suppose it was 20 meters. You could build 2 20-meter low-pass filter kits and put them into 2 of the slots on that relay board, and configure the Ultimate 3S so that it transmitted alternately into one and then the other. To identify the reports of which came from which antenna, several ways you could do that. You could either do that by having them operating on a different frequency. So the Whisper subband is 200 hertz wide. You could, for example, transmit one in the lower 100 hertz and on the other antenna in the upper 100 hertz. So you could differentiate them by frequency. You could also just differentiate them by the transmission slot. So if you have one going at 2 minutes and 12 minutes and 22 minutes past the hour, and the other one going at 4 minutes, 14 minutes, 24 minutes, 34 minutes, etc., for example, then you'd know that every report that came in where it was at 4 minutes into a 10-minute cycle was coming from one antenna, and the 2 minutes in was coming from the other antenna. That would be another way. Still another way would be to configure them with different power output levels, although you'd then be transmitting it. You'd obviously want to transmit at the same power output level to make a comparison of the antennas, but you could configure them so that they appeared as a different power output level in the decoder's Whisper. It's probably a less preferable option because you're then transmitting at a power output level that you're not actually using according to the way that it's appearing on Whisper. But I would say the easiest way is just the time slot method. You'll always know that one is on the second slot and the other is in a different time slot. But yeah, it's a very interesting use of the kits and the modules in comparing antennas.
Yeah, it is. I wasn't sure about the time slot, if that would be reliable or not, but sounds like it is.
Well, especially if you're using a GPS, if you've connected the GPS kit, then everything will be very reliable about time slots.
Okay.
If you're not using a GPS kit and you're going to not necessarily be on the same guaranteed on the particular time slots, then the frequency method would be fine. Of course, not all the receiving stations are completely accurately calibrated, but certainly you'll be able to differentiate between whether one's in the lower 100 hertz and the other's in the upper 100 hertz. That would be no problem.
Is that programmable?
That's programmable, absolutely, yeah. So on the Ultimate 3S kit, you can exactly program the transmission frequency that you want to use. Yeah.
And you can change it back and forth.
Yes, I mean, on the Ultimate 3S, you can configure up to 16 different transmissions, each of which can be on a different frequency, a different relay of the, if you have the relay board fitted, a different mode, so they don't all have to be whisper, a different power level. Everything is configurable. So each of those 16 slots can be different frequencies, different modes, different everything. So it's very, very flexible.
Okay, thanks a lot.
Thanks.
Well, that's
Thank
great.
you.
Barry, there's a couple more on the chat. You want to pick those up?
Okay, this is a two-part question. It says, thanks for the presentation. What PCB design software do you prefer to use or use?
I'm using Eagle. I've been using Eagle for 10 years, and it just happened to be the first thing that now we've got KiCad, which is becoming very popular, and it's a free open source PCB design tool. But 10 years ago, that was, I don't think, available, or if it was, it certainly wasn't popular yet. And Eagle was the popular tool to use, and it was available free also. And that's also what determined, by the way, this is interesting, that's what determined the size of the QCX PCB. So the QCX is 10 centimeters by 8 centimeters, 80 square centimeters, and that's the limit of the size that you could do in the free version of Eagle. And, being a frugal ham, I wasn't going to pay for the licensed version of Eagle. I wanted to continue using the free version. And so that was what I used. And also, there's a limit in the free version of double-sided PCBs. So you can't have like 4-layer and 6-layer PCBs. I personally don't like to use multi-layer PCBs anyway on a kit, because I think if people want to modify, or if they want to repair something, or that you really want to be able to see all the tracks everywhere anyway. You don't want hidden things in the middle layers of the PCB on a kit, in my opinion. And so I was perfectly happy with that limitation. But then in this year, when I produced the QCX Plus, the main board on the QCX Plus is 13 centimeters by 10 centimeters and no longer fit that free version of Eagle. So I've now upgraded to a pay version of Eagle. It was very expensive. It's now part of the Fusion 360 product. The company has changed ownership several times in those 10 years. And it was something like $300, and I have to pay that every year. It's an annual subscription. It's quite pricey. But, I could move to KiCad and it would be free, but I think the amount of time I would invest in relearning everything would make it not worthwhile. And I've become very quick with Eagle PCB, and I can create new component footprints for things which I need, which don't have a standard library footprint and everything. So I'm very happy with Eagle PCB, and that's what I use. I've used the last 10 years.
Okay, great. Second part of the question, what test equipment would you recommend after a DVM and an oscilloscope?
Well, the next test equipment that I like very much is the spectrum analyzer. And the spectrum analyzer can be a very expensive piece of equipment, but I don't know if you've seen this. There's now this very low cost, and I was involved in the beta testing program for this. It's a very low cost spectrum analyzer, which is, it fits in your hand. I
Wow.
don't know if people have seen this, but there's this, and then there's a network vector analyzer, which is a similar size and similar price. And this is available for under $50, this spectrum analyzer kit. And it's not got the same performance as a $1,000, $2,000 professional spectrum analyzer, but nevertheless, it has about 70 dB of dynamic range, and it goes well up into UHF. And so it's perfectly adequate for testing things like transmitter harmonic output. And so, you know, the DVM is the first thing that everybody should have. Oscilloscope is an optional piece of test equipment, very, very useful. And, you know, I use mine every day, oscilloscope. But this spectrum analyzer is probably the next most important thing, I would say. Of course, opinions will vary on this, and a lot of people will want things like signal generators. But I personally don't have any signal generator other than the QRP Labs kits. So the QRP Labs VFO signal generator kit is what I've been using as my signal generator. And the QCX has its own built-in signal generator. So I haven't seen any need for anything else than an oscilloscope and a spectrum analyzer. And as I said, spectrum analyzer used to be a very expensive piece of equipment, but now you've got this beautiful color screen, tiny thing, which really works pretty well. It has about 70 dB of dynamic range on it. Very much recommend that. It's called Tiny SA. So if you look at eBay or AliExpress, you can see this Tiny SA thing. I would recommend that to anybody. It's a very nice piece of equipment.
Hey, that's all the questions in the chat, Dan.
All right, looks good. Lee, do you see anything out there we might be missing? You're muted, Lee.
Sorry about that. Yeah, no, I don't see anything else. I got a quick question. Hans, has anybody managed to fit the QCX into the QCX Plus box yet?
Has anybody managed to fit the original QCX?
Yes, into the enclosure of the QCX Plus.
Not, I haven't heard of that.
Right.
But there's no reason why it wouldn't be possible. I mean, the original QCX, one of the things which I provided was pin headers near the edge of the board so that it was easy to mount the controls off board, and which many people did when they were developing the enclosures for it. And so it would be quite possible to put that in a QCX Plus enclosure. I haven't heard of anybody doing that yet.
Riley,
I've heard of people putting things like batteries in the top half of the enclosure. There's a lot of space in there. You know, you can see in the pictures, there's a lot of space, and the development kit board provides a nice platform for people who want to put stuff on in the top section of the box. And people have been talking about putting in tuners and batteries and speakers, things like that. But I haven't heard of anyone putting an old QCX in a QCX Plus enclosure, but they could, I think.
I think you just challenged Lee. All right, anything else, Lee?
No, I don't see anything else. Thank you.
Just so you know, their hands. Lee wanted to have a front row seat for this presentation. She's very fond of your products. Hans, may I ask you, can you send me your presentation? I'll put it in the PDF form and include it with the video, so the people that didn't make this tonight would have that to go with the video. Could you do that?
Certainly, that would be no problem. Yeah, I can send you that. How many people are listening, by the way?
Well, right now we've got 62. It was at 80 something. That sort of happens because of the time frame. But we get a lot more people when we send out we send out mass emails, goes out to hundreds of people. And I look at the video, and we get a lot more people looking at those videos afterwards. So it works out pretty well.
Tonight is a tough
Okay, great.
because there's the political debate on.
Say again, Barry?
Tonight was a tough night because we had the political debate on TV. Got a lot of people away. They'll probably be watching this later.
Yes, that's going on here locally. It's interesting. I sent you that the link for getting on this Zoom thing, and so you could share it. And all day long, I've been seeing people from all over the world getting on there, testing their equipment and stuff. I really expected a huge turnout tonight from international folks when everybody was on there.
But this is recorded. We'll be sending it out to everybody.
Yes,
Okay.
we will. We will. And any documentation. All right. This has gone on a little longer than normal, but it's in good timing. It's been a very good presentation. Really appreciate you doing this. Are there any more questions out there?
This has been amazing. Thank you.
Yes, it has been.
Thanks,
And the
Hans.
fact there's not a whole ton of questions usually says it's a real good. Okay, John, did you have a question? W0KMK, JMK?
No, I just said thank you to him, that's all.
Oh, okay.
We had someone checking in from Canberra, Australia.
DX.
Yes, little DX there. We have them from Spain. We have them from all over the place coming on these things. So, and again, we send out the videos, and I watch that to see who's watching those, and they just go crazy. All right. Well, unless there's some more questions or answers.
No, just to say thank you, Hans, from Canada. There's a bunch of us up here that really enjoy building and operating your kits, and thank you very much for what you do to the CW and kit building community. This is Dave in British Columbia.
Thanks very much, Dave. Thanks everybody for watching. And if there are any other questions, then you know, you can contact me on email or via the email on the last slide, or even on the website. You can just click on the contact form and so on. I'm always very happy to answer all the questions, and I'm very much enjoying the new career that I have made in QRP Labs. After 22 years developing software in banks, I really felt that I was kind of halfway through my working life, and I couldn't really face another 20 years doing the same thing. But now I'm very happy doing the QRP Labs kits and in the hobby which I love, and feel very happy coming to work every day on these projects. And not always easy. Sometimes a lot of support requests and difficulty with parts and manufacturing and so on. There's all those aspects to it which make it much more difficult than just sitting here playing with soldering and firmware. And but it's very enjoyable, and so thanks for your support, Dave, and everybody else, and thanks very much for inviting me, Dan. It was a pleasure.
Pure pleasure for us. It really was. Appreciate you coming on. All righty. If you got some more things later on you wanted to show and tell us, you said you had some other products that you were modifying and that kind of stuff, get a hold of us and we'll see if we get you back on here to show those things.
Thanks very much, Dan.
All righty. With that, I'm going to make one more swing to see if anybody's got any questions, comments.
I don't see anything else in the chat box, no.
Okay. All righty. Well, I want to pull the plug here, 7371. Everybody, please stay safe.
Thank you all.
Thank you.
Yeah, 7-3.